if the function itself is considered a do action, then the inverse is the undo. So basically what the inverse function does is it reverses what the other function has done. So consider the function f of x is equals to 3x plus 2. We can write this function using a flow diagram. So what basically this function does is that it takes x, the input, multiplies it by 3 to end up with 3x, and then adds 2 to give you the output, which is 3x plus 2. But now what the inverse function of f of x will do is that it will start from the other end, and the results of what is on the other end will be its inputs. So we start from the other end with x, because that's now the input for the inverse. And then it performs inverse operations here. So the inverse of adding 2 is subtracting 2, so we end up with x minus 2. And then the inverse of multiplying by 3 is divided by 3, so you end up with x minus 2. So basically what you're saying here is that if we are given a function, say f of x, yeah, we can work out the inverse of that, yeah, inverse of f of x. Now the notation for the inverse function is this. This is the notation for the inverse function, and f to the power negative 1x, but it's called the inverse of f of x. And of course, you have seen here that the inverse of f of x, which is 3x plus 2, is that. And therefore, we can say that if f of x is given by that, then the inverse of that function, which is written like this, will be equal to x minus 2 divided by 3. So obviously, that's one way of finding the inverse functions, by using a flow diagram. But there's also an algebraic method which you can use to work out the inverse function. And this is basically our area of interest. So how to find an inverse function algebraically. So step one, um, if you're given an inverse function, an original function, in this case f of x equals 3x plus 2, the first step is to change f of x to y. Yeah. So change f of x to y. So basically what you'll end up with here is y is equal to 3x plus 2, which is just an equation. Step 2, interchange x and y. So interchange x and y. So you'll have x is equal to 3y plus 2 from here. Step 3, solve for y. Solve for y. So if we want to make y the subject of the formula, we'll end up with x minus 2 is equals to 3y, which implies that y will be equal to x minus 2 divided by 3. Step 4, change y to that notation there, because this is now the inverse of that function. So change y to that, because remember here we're looking for the inverse function. So the inverse function of f will be x minus 2 over 3. Okay? And you can see it's the same result as what we have here. So ideally, these are two methods on how you can find the inverse function. You can use the flow diagram, or you can use the algebraic approach. Of course, the most common method is the algebraic approach. So I'll be using the algebraic approach for all these questions. So number one, find the inverse function for the following functions. So we first of all change f of x to y, and then we can expand the bracket as well. So so that will be 4x minus 20, and then we can switch x and y, interchange x and y. So x will be equal to 4y minus 20, and then just make y the subject. So y will be equal to x plus 20 divided by 4, and this is basically the inverse function. Okay, same approach as what I've just explained. And the same approach applies here. So start by changing f of x to y, interchange x and y, then make y the subject. So the opposite of dividing by 5 is multiplying by 5. So y will be equal to 5x minus 4, and that's basically the inverse function. Number 2. So here we have an original function, and we expect it to find the value of its inverse at x is equals to 2. So the first step is we change f of x to g of x to y. So we'll have y is equal to 2x plus 5 over 3. And then we interchange x and y. And then the opposite of dividing by 3 is multiplying by 3. So we have 3x minus 5 is equals to 2y, which implies that y will be equal to 3x minus 5 divided by 2. So the inverse function here will be equal to 3x minus 5 divided by 2. But what we are interested here is, sorry, this is actually g, not f. We are interested in the value of this inverse at x is equal to 2. So we plug in that. So the value of the inverse function at x is equal to 2 will be 3 multiplied by 2 minus 5 divided by 2. So that's 6 minus 5 over 2, which will be equal to a half. Number 3. So we have a function f of x, and we are required to solve for the values of x where this function is equal to its inverse. So let's first of all start by finding its inverse, and then we'll just equate them and solve for x. So y will be equal to x plus 5 over 2. Switch x and y, or interchange x and y. Solve for y, so 2x will be equal to y plus 5. So y will be equal to 2x minus 5. And that's basically the inverse function. But we know that the original function is equals to its inverse. So basically, x plus 5 over 2 is equal to its inverse, which is 2x minus 5. And then we want to solve for x. The opposite of dividing by 2 is multiplying by 2. So x plus 5 will be equal to 2 multiplied by 2x minus 5. So x plus 5 will be equal to 4x minus 10. And then subtract x from each side. So we have 5 is equals to 3x minus 10. add 10 to each side. We have 15 is equals to 3x, so x will be equal to 5. And that's basically how you solve that question.